All right, so we're going to take a look at how to calculate slope from a few different situations. So on this first page, we have a bunch of graphs. So we're going to talk about how to calculate slope from a graph first. So remember that when we calculate slope, it's sort of just like rate of change. It's how much did the y change divided by how much the x changed. But when it's a graph, instead of thinking about how much the y change and how much the x changes, we use a different phrase to help us remember how that works on a graph. That phrase is rise over run. So rise over run is how I calculate my slope. Whenever you do rise over run, always start from your left point. You're going to need 2 points, so they kindly labeled 2 points for us here, but you're going to start from your left point. So this is my left point. I'm going to start with that one. Then, once you're started at your point, you always want to go in order. So it said rise over run. That means you're going to rise first, either rise up or rise down, depending. And then you're going to run to the right. You always want to be moving forward to the right. So let's start from my first point and do my rise. So I'm rising until I reach the height of my other point. So in this case, I need to go down how many boxes? Going down 1 box to reach my point. Since I went down, do you think it's going to be positive or do you think it's going to be negative? Well, going down means it's going to be a negative rise. So I went down 1 unit. My rise equals -1. And if you start with rise and you start on the left, your rise will tell you if your slope's positive or negative. Once you've found your rise, we're going to do the same thing with run. So where I left off, I'm going to count how many units until I reach my second point. So how many jumps do I do? 1, 2, 3. So my run is 3. And if you do rise first, run second, your run should always be positive. So my rise over run is -1 divided by 3, and you can just leave it as a fraction. If you need to, put it into Desmos, and you can see what the fraction turns into a decimal, or what the fraction is as a decimal, -0.333 repeated. All right, so there's one graph. I'll do one more example of rise over run. So number 2, try it before you do it, before I do it. Maybe pause the video here. Find your 2 points and do rise over run. So I'm going to go ahead and start now. Hopefully you paused it. Here's my left point. I'm going to start with that. My rise, how much does it take for me to reach the height of this other one? Is 1, 2, 3. This time, did I go up or down? Up. So my slope, or my rise, is +3. So rise equals 3. Now we do the same thing with run. So where I left off, back to the second point, I ran 1 unit. So my rise is 3, my run is 1. We always set it up as a fraction. Rise divided by 1. What's 3 divided by 1? 3. So my slope, which we call m, equals 3. All right, let's take a look at a different type of problem. The next type of problem is where they give you points. So these pair of points can be used to find your slope. We've learned 2 different methods. I'm going to show you the slope formula method here and then the table method here. And you can pick the one that you like better. So first, the slope formula method. Remember, your slope formula is y2 minus y1 over x2 minus x1. And you're going to plug in the points where they go. Remember, we've got to name our points. So this is x1, y1, x2, y2. Now I'm going to go ahead and plug everything in. So my y2 becomes 14. I plugged in the y. My y1 is 10, so I'm going to do minus 10. Next up, my x2 is negative 7. My x1 is 8. I'm going to do minus 8. And this is where I would recommend taking this and doing it in the calculator. So I'm going to open up a tab of Desmos, and we're going to plug in exactly that equation. Okay, so remember FRAC to make a fraction, 14 minus 10, and negative 7 minus 8. This gives me a long decimal, but just click the fraction button, and my answer is negative 14 over 15. That is one way to do it, just plugging in the numbers until you find your slope. So there's the slope formula method. The other method you might prefer is setting up a table. So remember, it's always x on the left, y on the right most often, x, y, x, y. So I'm going to plug in these points. Negative 3 and 1, negative 17 and 2. Once you've set up the table, remember slope is just the same as rate of change. Change of y over change of x. Now I just need to calculate. How much did my y change by from 1 to 2? Well, it went up, so it's positive. Went up by 1, so my change of y is 1. How much did my x change from negative 3 to negative 17? Think about it. It went down, more negative. It went down by 14. So now I have my change of y, my change of x. It's 1 over negative 14, which means it equals to negative 1/14. These are your two methods. You need to find one that works for you, whether it be the slope formula or the table method. The next one, we need to do the same thing. It's a table already, so you might as well do the table method, but you can still do the slope formula. Just have to name your points. So again, I'm going to do two problems from this one, and I'm going to do one of each method. So the first one, I'm going to do the slope formula. Label your points. x1, x2, y1, y2. Your y's get a name, your x's get a name. Now we plug in the points. Hopefully you have it handy, but if you don't, the slope formula, y2 minus y1, x2 minus x1. y2 is 4 minus 19. x2, negative 1, minus, and this is where it's really important to do parentheses. It's always minus the number. So it's going to be minus x1, which is negative 4. So again, we're going to take this, we're going to put it into Desmos and get out the answer, because these can be really tricky, so we might as well use our calculator to help us out. Negative 1 minus negative 4. there's my slope, -5. All right. Now on the other one, I'm going to show you how the calculator might be able to help you see the change of y. So if I want to know how much did I change from one to the other, all you have to do, if you can't tell that it's going up by 1, then this is how you're going to do it. You're going to take the first one and you're going to subtract the second one to see how much did it change. I went from -7 to 6, so my change of y is +1. Same thing for my change of x. If you can't see just by looking that it went up 3, you take your first one or your second one and you subtract minus your first one. And I got +3 as well. So change of y over change of x is equal to 1/3. That's my slope for that one. Okay, I think there might be one other type of example. I'm actually going to have you guys not worry about this last section. We're not going to worry about this last section for now. Yeah, don't worry about that. I'll explain that another day. Just make sure you can calculate slope by hand, either using rise over run, or by using the slope formula, or by using a table and finding the change of y over the change of x.